I am Anil Kumar sharing with you another brilliant question based on complex numbers shared by our subscriber. It has three parts. We need to express minus 4 plus 4 square root 3I in terms of r e to the power of I theta, where r is greater than 0 and theta is between minus pi to pi. And then let the roots of the equation z cube equals to minus 4 plus 4 square root 3ib z1, z2 and z3. We need to then find the three roots. Once we find the roots, on the Argand diagram, z1, z2 and z3 are represented by the points A, B and C respectively. Find area of the triangle ABC. Beautiful question. Once you go through the solution, all your concepts will be absolutely clear. So we'll begin with the complex number given to us, which is, let me write this as z equals to minus 4 plus 4 square root 3I. We can take 4 common, and what we get here is minus 1 plus square root 3I. To write it with sine and cosine, let's divide by 2, right? Why 2? Because, let me write here, minus 1 square plus square root 3 square is what we multiply and divide with. So this number, as you can see, is 1 plus 3, which is square root of 4, which is 2. So we are going to multiply and divide by it. So it becomes 4 times 2, and the other 2 will take inside. So minus half plus square root 3 by 2. You get the whole idea, right? So when you multiply and divide by the same number, the expression remains same. But that gives you an idea that what minus half could be and what square root 3 by 2 I could be when we are working in the domain minus pi to pi. Also look at a special triangle. Let me make the special triangle here. I'm using all the space provided to me. So 30, 60, 90 or pi by 3, pi by 6, pi by 2. So as you can see, the cos value of minus half means that angle. And minus means we are in quadrant 2, right? Then only it will be this. So that angle is 2 pi by 3. So I can write this as 4 times 2. So I'll write z equals to 8 cos of 2 pi by 3. And that is sine 2 pi by 3 plus I sine of 2 pi by 3. Now, using Euler's formula, you could write this as 8 e to the power of I 2 pi by 3, correct? So that's how we can represent minus 4 plus 4 square root 3I in terms of r e to the power of I theta. Right? Theta is 2 pi by 3. So we've done the first part. I hope the steps are absolutely clear. Let's move on to the second part where z cube is the same function, which is, we can write this as z cube equals to 8 e to the power of I 2 pi by 3. You get the whole idea. We could think like this. And we need to find all the three roots, right? Let's move on the next page to solve it. Okay, great. So part A we have 8 e to the power 2 pi by 3. Part B is let the roots of this equation be z1, z2 and z3. Find these roots. So since z cube is equal to minus 4 plus 4 square root 3i, z will be square root of all this, correct? And we have already seen that this is equal to 8 cos of 2 pi by 3 plus I sine of 2 pi by 3. We could have also written in terms of 8 e to the power of 2 pi by 3. All right, that was actually better. Anyway, we wrote like this. So z will be what? Z cube is this, so cube root of this, right? So 8 cube root means, okay, we'll do right like this. Cos of 2 pi by 3 plus I sine 2 pi by 3 cube root. So 1 over 3. Is that clear to you? So that is how we can write z. Now, we need to provide the three roots. Cos and sine are periodic functions. So they are going to repeat after every 2k pi, right? So we could rewrite this as 8 to the power of 1 over 3, which is 2. So let's write 2 here instead. And here we can write that space will be insufficient, so I'll have to write here only. So z equals to 2 cos of 2 pi by 3 plus 2k pi plus I sine 2 pi by 3 plus 2k pi. K has integer values to the power of 1 over 3. Correct. Now, using the formula, we can now rewrite this as 2 dividing everything by 1/3, right? So it will be cos of 2 pi by 3 dividing by 1/3 will make it 9, or multiplying by 1/3 will make it 9 plus 2k pi by 3 plus I sine. So let me put this in brackets. Sine, better to put this in brackets. So 2 pi by 9 plus 2k pi by 3. Correct. So that becomes our equation. Now we can put different values of k to get our solution, right? So the solution now is, you can write in terms of using Euler's formula as 2 e to the power of, that gives you 2 pi by 9 I 2 pi by 9 plus 2k pi by 3, right? So you could write like this. Now, substituting values of k to find the three roots, we can put the value of k as -1, 0 and 1 to get the three roots, right? So let's take it to the next page to write down our solution. So what we did was, in our equation, we substitute the values of k as -1, 0 and 1, and we get the solution, which is z1 is 2e to the power of -4 pi by 9, z2 is 2e to the power of 2 pi by 9, and z3 is e to the power of 8 pi by 9. Right? So that's how we get all the three roots, right? There was insufficient space here. We kind of substitute these values here and get you three roots, right? Which are these? So now we go to the next part, which is we know that the roots are given to us. We need to find area of the triangle found with triangle ABC. So on the Argand diagram, let me just so we have already have a circle here. Correct. So the first root is 2 e to the power of minus 4 pi by 3. So 2 is the radius of this circle, right? 4 pi by 9 will be minus 4 pi by 9 will be somewhere here, right? So this angle becomes minus 4 pi by 9. The next one, this is point A, let's say ABC, is 2 pi by 9, 2 times. So 2 is the radius, e to the power of 2 pi by 9. So 2 pi by 9 will be somewhere here. Let's call this as B. This is 2 pi by 9. And then we have 8 pi by 9, which is going to be something like this. C. So 8 pi by 9 from here. Correct. So these are three points on the circle with radius 2. So let me write this as minus 2 and 2 here. Makes sense. So that becomes our Argand diagram. So we have a triangle whose area we need to find. Correct. So in this triangle, you'll notice that there are three triangles in between. Let's say O is the center. So we have got three triangles whose two sides are 2 each, right? I mean, because of the radius. And what is the angle in between? As you can see, the angle in between is, let's figure out the angle first. So angle AOB is basically 4 pi by 9 plus 2 pi by 9, which is 6 pi by 9, or dividing by 3, we get 2 pi by 3. So 2 pi by 3 is the angle. Similarly, in the other cases, the angle COB is 8 pi by 9 minus 2 pi by 9, which is again 6 pi by 9 or 2 pi by 3. So what we have is all three are exactly same congruent triangles with two sides as 2 units and the angle between them as 2 pi by 3. Correct? Isosceles triangles. So the total area will be 3 times the area of each triangle. Correct? So the area will be 3 times the area of each triangle. So we can write down area as 3 times area of each triangle half the sides product, which is 2 each, times sine of the angle in between, which is 2 pi by 3. And that is 3 times. So that 2 and 2 cancels. 2 times sine of 2 pi by 3 is square root 3 by 2. So that gives you the area as 3 square root 3 unit square. Correct? So that is how we find the area of the triangle ABC. Perfect? So that's how you're going to solve this particular question, which has these three parts. So I hope you have understood the strategy of solving. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your valuable time and all the best.